So we just discussed what is Newton's first law, and we actually concluded that it was a perfect statement that helps us understand what a force is, right? So before actually getting into Newton's second law, we are going to recall the acceleration equation, right? So we are going to understand what is acceleration for once again, and we define acceleration as the rate at which the velocity of something changes, right? So acceleration is always equal to the change in velocity with respect to time, and we can see that acceleration is always proportional to the change in velocity. If something's velocity is changing more, it is going to be accelerating more in that given interval of time. If something's velocity in a given interval of time is less, if something's the change in velocity is less, then the acceleration of that thing is going to be less. So acceleration is going to be proportional to the change in velocity. We are sure about this, that acceleration is always proportional to change in velocity, right? So this is the first thing we established. And now this del V thing, let's actually put some light on that. This is something that we just discussed in Newton's first law, that a force, a net external force, is something that always causes the change in velocity of something, right? So whenever we have net external force, it is going to create a change in velocity of something, right? So this is something we discussed in Newton's first law, and we are sure about it. So let's actually develop a proportionality in that case as well. So my claim is that whenever we apply net external force, it is going to be proportional to the change in velocity, because if we apply less net external force, it is going to cause less change in velocity. If we apply more net external force to something, it is going to change its velocity more. So force should always be proportional to del V. And since we concluded that acceleration is proportional to change in velocity, and net external force is something that is also proportional to change in velocity, hence we can conclude by logic that the net external force that we're talking about should also be proportional to the acceleration. So F is proportional to A. And this is nothing different. We have just been discussing that force is something that causes the change in velocity, and acceleration is basically a measure of change in velocity with respect to time. So force should always be proportional to acceleration. So this is so far Newton's first law, but Newton's second law is nothing different than that. It just gives a mathematical touch to the Newton's first law, and we have an equation. So whenever we in mathematics we convert the proportionality to equality, we get an equation. So F should be equal to and by fact we know that whenever we change the proportionality into an equality, we always have to take into account some constant, because we assume that whenever we apply net external force on something, it is going to cause an acceleration, but we need to assume something that has to stay constant. And in this case, we assume the mass of that thing needs to stay constant, because if we keep increasing or decreasing the mass of that thing, it is going to not cause the change in acceleration as we expect it to cause, right? So if, for example, this object starts to deteriorate and it starts to disintegrate, in that case, the acceleration is not going to to be caused as we expect it to be. Like so. The force will always be proportional to acceleration if we assume the mass of that thing to stay constant, right? So in this, whenever we change a proportionality to an equality, we have to take into account something that needs to stay constant. In this case, mass of that thing needs to stay constant. So we just take the product of mass and acceleration, and in this case, we conclude that force should be equal to mass into the acceleration. So if now something's mass increases, it is also going to affect the net external force that is required to cause the same acceleration. If the mass starts to decrease of that thing, then there should be less net external force required to cause the same amount of acceleration. So that makes sense. So F is equal to ma is indeed the Newton's second law, and it is nothing different than Newton's first law, but just is a numerical or mathematical version of that, right? So F is always equal to ma. Now, if you're given the mass of something, for example, the mass of this ball here is, for example, 2 kilograms, and the net external force that you apply to it is, for example, of 10 newtons, right? And with the help of Newton's second law, we can actually calculate the acceleration that this net external force is going to create in that. So how do we calculate that? We just need to rearrange this formula for acceleration. In that case, it is going to be A should be equals to F over m, and the force in this case is 10 newtons, and uh, the mass is 2 kgs, so the acceleration is going to be 5 meters per second squared, right? So it was pretty simple for us to now calculate the acceleration that was caused, or the change in velocity with respect to unit time. In in this case, it was pretty simple for us to calculate if we are given the mass or the net external force. Similarly, if you are given the mass and you are able to calculate the change in the velocity of that thing with respect to unit time, that is basically the acceleration. If you're able to calculate the acceleration, you're given the mass, you can simply take the product of them and you get the amount of net external force that was provided to it. Or in some cases, if you, for example, already know the amount of net external force that was provided to something, and you are able to calculate the acceleration of that thing, you can easily calculate the mass of that thing. So if you're given any two values of out of these three things, you can calculate the third thing pretty simply using the Newton's second law.